Question 2b. So for x and y, given that negative 2 over x plus iy minus 3 over 1 minus 3i is equal to 2. So let's see the solving. So exam 1 revision. Question 2b. You're solving for x and y given that negative 2 over x plus iy minus 3 over 1 minus 3i is equal to 2. So the first thing that we do here is we take this guy the other side and have negative 2 over x plus iy is equal to 2 plus is equal to 2 plus 3 over 1 minus 3i. This can be written as over 1 and then simplify. The common denominator on the right is 1 minus 3i. So get to 1 minus 3i plus 3 multiplied by 1. This implies that negative 2 over x plus iy is equal to 2 minus 6i plus 3 over 1 minus 3i. Then we'll cross multiply. So cross multiply, we get negative 2, 1 minus 3i is equal to, so we're crossing multiply. Now 2 plus 3 from this, 2 plus 3 is 5, and then minus 6i. So we have 5 minus 6i multiplied by x plus iy. This is what we have. And upon cross multiplying, since we're looking for x and y, we can divide by 5 minus 6i, divide by 5 minus 6i. And then we simplify on top, we have negative 2 plus 6i over 5 minus 6i is equal to x plus iy, because this is going to cancel this one. So that x plus iy is equal to negative 2 plus 6i over 5 minus 6i. Do the conjugation, we'll get 5 plus 6i as we conjugate, and down here 5 plus 6i as well, giving us negative 2 by 5, that's negative 10, and then negative 12i, and then plus 30i, then negative times negative, I times I, we get I squared. And so 6 times 6, we have 36. We're going to have 36i squared, but we know that I squared is the same as negative 1. So 36i squared is the same as negative 36. And then divide by 5 by 5, we get 25. When you're conjugating or rationalizing, you only multiply the first entry by itself and the second by the other. So negative 6i by positive 6i, we'll get negative 36. And then I times I, we get I squared, but I squared is negative 1. This will come out as positive 36. Then what we get next? Next, we get that negative 10 minus 36, that's negative 46. And then plus 30 minus 12, that's positive 18i. over 25 plus 36. What number do we get? 25 plus 36, we get 61. This means that we have negative 46 over 61 plus 18 over 61i. So that since on the left we also have x plus iy, on the right we have the real plus the imaginary, then we say x is a real part, negative 46 over 61, y is the imaginary part, 18 over 61. That is what we call the values of x and y. That is how you obtain. So what is key here is knowing how to conjugate, knowing how to solve. This is just about knowing how to multiply and how to add, how to deal with fractions. Question C.
So,
Hello.
yes. So when you just find, okay, why did you just assume that x and y are just respectively given as negative 46 over 61? Or maybe there's something.
Since we have x plus iy to be equal to negative 46 over 61 plus 18 over 61i, then we are saying y, which is the coefficient of I, should be the same as 18 over 61, the coefficient of I. So the numbers without I, the x without I, should be the same as negative 46 over 61 without I. Okay, so let's go to B. I'm going to C. Now C, show that x minus 2 is a factor of p of x is equal to x3 plus x squared minus 5x minus 2. Hence solve px is equal to 0. Sketch the graph indicating all the intercepts. So we do the solving. We first need to show that x minus 2 is a factor of f of x is equal to x3 plus x squared minus 5x minus 2. Hello.
Can you just bring the previous slide? I entered late. I just screenshot.
Cindy wenzo ponte.
Cheers. You narrating.
So for us to check that there's a factor, that this x minus 2 is a factor, you get x minus 2, equate it to 0, obtain the value of x as 2, then pick the 2. If what you get here is 0, then you say that x minus 2 is a factor. Okay, so we substitute 2 power 3 plus 2 power 2 minus 5 by 2 minus 2. This is 8 plus 4 minus 10 minus 2. This is 12 minus 12, which is equal to 0. So you say, since the remainder is 0, then x minus 2 is a factor of f of x. On the part of sketching, you need to indicate the intercept. So you can start with the y-intercept. When x is 0, we'll get -2. You substitute whatever is x, you take 0. So you get a constant -2. So the y-intercept is 0, -2. You go for the x-intercepts. As it is here, we already have a factor. X is equal to 2 is a factor. So you can directly use it in synthetic division. So we have -5 and then -2. Then 2 by 1, we get 2. Do the addition, we get 3. 2 by 3, we get 6. Do the addition, we get 1. And 2 by 1, we get 2. Do the addition, we get 0. So what we have now is f of x, might be written as x minus 2 multiplied by the quotient x squared plus 3x plus 1. Now, when you equate f to 0, then in fact it's been p. It's supposed to be p. So when you equate p of x to 0, we'll be equating x minus 2 x squared plus 3x plus 1 to 0, which is just saying x minus 2 is 0, or x squared plus 3x plus 1 is 0. Now here x is 2. Here you can use the formula -3 plus or minus the root of 9 minus 4 over 2. So we get -3 plus root 5 over 2, or x is equal to -3 minus root 5 over 2. So we have all the intercepts, so we can have our sketch. The y-intercept is 0, -2. So 0, -2. The x-intercept, we have 2. We have 2. We also have -3 plus root 5 over 2. And then we have -3 minus root 5 over 2. There's always a question of how do I know that this part here is negative or positive? Since we know that the root of 4 is 2, and the root of 9 is 3. It's obvious that the root of 5 is less than 3, but bigger than 2. But we have a negative 3. So since we have a smaller number, when you have negative 3 plus a smaller number here, you get a negative number, even if you don't know the actual value. And so now, if you can try, you go back in the function. Since here you don't know what our turning points are, I can go back to the function and try and see what I get when x is 1. The only whole number that is known to be in between this interval here, that is 1 plus 1 minus 5 minus 2, giving us negative 5. And negative 5 is bigger than negative 2. So this means that our graph will go this way, turn anywhere, cut here, and turn after the intercept. And this is how you sketch indicating all the intercepts. So even if you know how to solve for turning points, you only have to solve for them when they are asked in the question. There are so many things that we know, but you can't write them if you haven't been asked in an exam.
So I'm still not comfortable on how to graph there.
Okay.
Sir,
Hello?
now how do you know the turning point in terms of y-axis on those variables like negative 3, minus -5 over 2? How do you know that this is where I'm going to turn?
Ask your question again.
And sir, since one of them is positive, one is negative, how do you know that they're both on the same line as on the negative part? Yeah, that's where I'm.
So what you're calling negative,
So,
hello?
so yes, you can start on the x-intercept.
On the x-intercept, once you have the factorized thing, you equate it to 0 and get the values of x. So we have a factorized thing, equate each piece to 0, then here you use the quadratic formula. That's one thing you should know by heart. And then, when you get the values, the plus or minus, negative 3 plus root 5, negative 3 minus root 5. The question is not on negative 3. The question is on the root 5. Is root 5 bigger than 3? Now we're saying root 5 is not bigger than 3. Since we know that root 4 is 2, and that root 9 is 3, it's obvious that root 5 cannot be bigger than 3. So if I'm subtracting, if I have negative 3 plus root 5, this will be a negative number, because the root 5 is smaller than 3, and 3 is negative. And dividing by a positive number does not change the sign. If I have negative 3 and I subtract root 5, this is a negative number. Dividing it by a positive does not change its negativity. Now, how do I know which one should be closer to 0? You look at the quantity, this quantity here you are adding. So it will be small. So the smaller the quantity with a negative, the bigger it is than other negatives. And then you're not interested in the turning points. you're interested in the intercepts. The only thing you do is that around this y-intercept here, you check where there's a whole number. First thing is that you check the bigger space. And you always suspect that in the bigger space, that's where the other turning point is going to fall. So now you try. We know 0 is the x coordinate for this y-intercept here. So you pick a number bigger than 0. That is a whole number if you see a whole number there. Now here we have seen that there's a 1. So having a 1, we've gotten this one, tested it in the original function and see if it will give us a value lower than -2 or bigger than -2. And it has given us -5. Meaning that the graph goes lower than -2 on the right of the y-axis. That's how you know I'm going to turn from there. This is pure polynomial. There's nothing to do with calculus. So you must not be worried about how to go about this stage here.
Then, sir, in our equation, +3 was positive. Then when we had to compute it in the equation, it became -3.
Like the formula is x is equal to -b plus or minus the root of b squared minus 4ac over 2a. Is that okay?
Oh, yes, sir.
So we've now answered the question of how has it become negative.
So can you bring back the previous page? Thank you.
Hello.
Yes, like on the graph, like how do you know that's supposed to be turning like that? I just want to know how you know that it's going to turn in that certain manner.
You look at how the points are scattered. For you to touch all the points, you can only go through this. You only have this orientation. If you made a mistake and use this orientation here, and you want to cut through all the points, are you seeing?
Yes, sir.
Very disorganized, is it? And you don't know where you're turning from there. Or if you had made a mistake, you start from this direction. I don't know where you would turn from for you to come to this. I don't know what to turn you for you to come to this, for you to come to that. When you claim that you have solved for all the x-intercept, but you have an x-intercept here that is unknown. So you look at how the points are scattered. And then the points will tell you which direction you must take for a graph to make sense. In a case when you don't know the turning points. If you involve calculus and you're asked to find the turning points, well, it becomes easy because you even know that here there must be turning point. As it stands, we don't know the turning points, so we just know the turning spaces.
But what about when x of x was 1? We found -5, but why did you indicate that?
No, that -1 was just giving us an idea that the function will go down after -2. Because if we didn't have this information, then we are going to sketch a graph in this manner. 10 here. Like that, would have assumed that it's a turning point. Or would have said this graph is coming down and 10 there. So any wrong assumption on these sketches, the sketch becomes wrong. That's why we need the correct assumption in terms of which space you have a turning point.
But since in the question they did not say find the turning point when x is 1, when x is 1, sir. So why did you choose 1? Is it because in the first place you chose x to be 0?
No, we are looking at the bigger space between this point here and this and this. Which space is bigger than the other? And then we suspect that the turning space is going to be this space here. And this space has got an advantage because we have a whole number 1 that lies in here. At least we are sure 1 lies in between 0 and 2. That's why we have used 1, because it's a whole number and it lies in the space that we are checking if it contains the turning point.
Now, sir, I've got a question. Let's say the way we often, if you had time, let's say I'm solving this question and then I'm not sure like where I'm turning on. Can I use calculus? I differentiate and then I put those x coordinates so that I can find like where the y values, so that I know okay, this graph is going like this. If you have got time, can I do that?
You can.
All right, thank you.
Okay, so let's log out quickly and log back so that we can start question 3.